and welcome back to Part 3, Inequalities with Radical Functions. So inequalities are going to have an additional step compared to the stuff that we have been doing in Parts 1 and Part 2. And the reason for that is with a normal square root graph or cube root graph or fourth root graph or whatever, if you get one answer, it's easy to check and see if the answer that you got is on the graph or if it's on a part that's not included in the graph. With inequalities, we're going to get a whole range of answers, but not all of our answers are going to be included in the graph. So we're going to have to make sure that the values we're getting for x are part of the domain. So the first step, though, is going to be very similar to what we've done in the past. We're going to go ahead and get the square root or the radical alone. And we're going to undo the radical by raising both sides to a power. And we're going to solve the resulting equation. Now we get x is less than or equal to 7. So you can imagine on a number line, here's 7, it is a filled-in circle, and we want everything less than that. But the problem is not all values of x, if we were to plug them in, if we pick a number less than 7, would work. So for instance, if I plug in -10 for x, I would get -50 and -60 under there, and we can't have that negative sign under the radical. So what we're going to do is we are going to take whatever is under the radical. In this case, it is 5x minus 10. And we're going to say this can't be negative, meaning it has to be greater than or equal to 0. Otherwise, those values for x don't exist on my graph. So if you add 10 and divide by 5, you get x is greater than or equal to 2. So on your graph here, you're also going to include everything greater than or equal to 2. So the only values that work in our final answer are going to be what works in both of these. So we are looking for the overlap in this case. So for this, it's going to be everything in between 2 and 7. Those are the values that work. Or if you'd prefer, you might see it like this, x such that 2 is less than or equal to x, which is less than or equal to 7. Now, to summarize here, you solve it like normal, and you graph it on a number line. But then, if you have an even index, I'm going to put this at the top here and highlight it. If you have an even index, those are the problems that have the restriction on the domains, because you can't have a negative underneath there. What you have to do is you have to take the radicand, aka the part under the root, or the square root, and you have to set it greater than or equal to 0. So the radicand has to be greater than or equal to 0, no matter what your original inequality started with. But once again, this is only for roots or inequalities that have an even index. So let's take a look at another one. So example 6 here. So we're going to go ahead and add 2 to the other side. We get 9 minus 5x is greater than 8. We're going to go ahead and square both sides. So we get 9 minus 5x is greater than 64. And we're going to continue to solve. That's a 55. There we go. And when we divide here by a -5, we have to switch our sign. So it becomes x is less than -11. So if here's our graph grid or our graph, we do -11 and we want everything to the left of that with an open circle. Now, because this is a square root, we're going to take the radicand, so 9 minus 5x, and this part that's under the square root has to be bigger than or equal to 0. We cannot have any negatives underneath there. So we get -5x is greater than or equal to -9. And when we divide by a -5, we switch our sign. So we get x is less than or equal to 9/5. So on our graph over here, we're going to put 9/5. This is a filled-in circle, but we want everything less than that due to having to switch our sign. Now we are looking for the overlap. So the overlap is everything that works in both of those, which means we cannot include negative 11 in our final answer. So our final solution is negative infinity to negative 11, or x is less than negative 11. So let's take a look at some other different contexts that might pop up. So let's try number 9. So we're going to go ahead and we're going to subtract 12 from both sides and divide by 8 and reduce. Now x to the 1/4 is the same thing as the 4th root of x. Now I'm changing forms here to kind of help us think about this one a little bit more. If we're looking at the 4th root of x, we cannot have a negative inside the 4th root because we will not get anything back out. There's no real solution. It's not like a cubed root where you'll get a negative number back out. For this one, if you take the 4th root of x, you're always going to get a positive number. So if you're comparing that and saying that x, whatever you get out, has to be less than negative 3/2, that is never going to happen. So this is going to end up being no solution. This happens sometimes when you are solving square roots, 4th roots, 6th roots, any even root. If you get that an even root is compared to a negative number, and specifically that even root is less than that negative number, that's not going to happen. That would be no solution. Whereas if you had the 4th root of x is going to be greater than negative 3/2, well, that's always going to happen. So you would keep on going for this one and you would solve that. And then you would go ahead and do your domain restriction and do the overlap of all real numbers and x is greater than or equal to 0. So there are some rare instances where you can take a look at the inequality and say, hey, that's not going to work. But if this were a cube root or a 5th root, you would have to keep on solving. Let's see an example of a cube root then. Like how is this different than the other ones? Well, we're going to start off by first dividing by 5. Then we're going to go ahead and raise both sides to the 3rd power to undo the 3rd root. So we get negative 1/2 x plus 4 is greater than 8. So continue to solve, making sure to multiply by that negative and change your sign. So if we have negative 8 on our number line, we have a filled in circle and everything to the left. Because this is a cube root and not an even index, we're done. We actually don't have to do anything else. Our final answer would be negative infinity to negative 8. And if you might be questioning, well, why is that? If you think of the graph of a cube root, all answers work. So you don't end up having any domain restrictions on this one. So that kind of goes back to what we were saying up here. If it's an even index, that's where you have to set the radicand greater than or equal to 0. So thank you very much for listening. I hope this helped.